Hi everyone, let's start paper 4 of A2 chemistry, October-November 2024, variance 41. Question number 1. Disodium phosphate reacts with an acid to form monosodium phosphate. Identify the ions that are conjugate acid-base pair in this reaction using the formulae of the species involved. Okay. Now the first clue is if this involves in the reaction with acid, which means it will accept proton. If it will accept proton, obviously it's going to be salt. Okay. Or you can say conjugate base. Because it's going to accept hydrogen ion. And since it has more hydrogen atoms in this ion, obviously it's going to act as an acid or conjugate acid because it donates its proton. Okay. So the conjugate acid is basically an examiner is looking for the ions actually. Okay. So I'm going to write conjugate acid is H2PO4 negative, and conjugate base is basically your salt, which is going to be HPO4 2 negative. Now the next is define buffer solution. A solution which maintain its pH fairly constant even upon the addition of a small amount of acid or alkali. Write two equations to show how the mixture of this acid and this salt can act as a buffer. So this is your acid. Obviously, it's going to donate its proton when treated with hydroxide ion, converting into water and salt, which is HPO4, and charge has to be 2 minus. Okay. Now HPO42 minus is basically conjugate base. It will accept hydrogen ion and will turn to an acid, H2PO4 negative. I think we have done such sort of equation in the class, all right? Identify one inorganic ion that acts as a buffer in the blood. So examiner is looking for the one inorganic ion. So it's going to be hydrogen carbonate. And hydrogen carbonate has a charge of -1, okay? Compound E is the hydroxide of group 2 element. Compound E is a strong alkali. So group 2 का जो strong alkali है वो technically barium hydroxide होता है because it is soluble in water and give you a colorless solution. So might be this compound E is barium hydroxide. In order to confirm this whole assessment, examiner has given us some sort of values. Examiner has given us the mass of compound E, and we need to make this in 250 cm cube of solution. Solution F has a pH of 13.09 at 298 Kelvin. Show that the concentration of hydroxide in solution F is this. Okay. So the concentration of hydroxide in this, and we need to prove that. So we have pH value. So pH plus pOH equals to 14. So from here, I can find the value of POH, which is 14 minus 13.09. So the POH is basically 14 minus 13.09 is going to be 0.91. Okay. So by using this POH value, I can find the concentration of hydroxide ion by using this expression. So it's basically shift log minus 0.09. Oh, sorry. Shift log minus 0.19. So shift log minus 0.19. So it's going to be 0.6. 0.645. Let me check. Shift log minus 0.91, 0.123 mole per dm cube. Okay. 0.91 equals to minus log concentration of hydroxide ion. So the value is going to be 0.123. Explain why the concentration of compound E in solution F is 0.0615 mole per dm cube. Okay. Examiner is looking for the concentration of compound E, and compound E is basically the group 2 hydroxide. So group 2 hydroxide generally can be represented by EOH taken 2, right? So let me compare EOH taken 2 will turn to E2 plus and 2OH minus. According to the equation, we have 1:2 ka ratio. If the concentration of hydroxide ion is 0.123 molar, molar means mole per dm cube. So the concentration of this is going to be 0.123 divided by 2. So it's going to be 0.0165. And that's the value of concentration given in the question. So this concentration can be determined on the basis of this molar ratio, all right? So what we can write here is both group 2 hydroxide and hydroxide ions exist in 1:2 respectively. Okay. Use the concentration given in part 2 to identify compound E. So I know the concentration. Okay, I know the concentration of compound E. This concentration exists in is 0.0615 mole per dm cube. So look at this value also. We need to consider this value. Okay. So in the first part, 1000 cm cube of E contain 0.0615 moles. अगर हमने 250 cm cube यूज किया है, so if we use 250 cm cube of E, so moles is going to be to say moles of compound E into 250 divided by 1000. So I'll get 0.015375 moles. All right. In the second step, I know the mass, I know the moles, I can find the MR. In the second step, let's find the MR. So mass is basically 2.63 divided by 0.015 375. So the MR would be 2.63 divided by answer. So MR is 171.05. All right. Now EOH taken 2 is the formula of group 2 hydroxide, which is equal to 171.05. Now E plus hydroxide has a MR of 17 multiplied by 2 equals to 171.05. Then E plus 34 equals to 171.05. So E is going to be minus 34, 137.05. Now this value suggests that E is barium. Oh, and it means that group 2 hydroxide is basically barium hydroxide, hence proved my statement. Okay. Next, compound E is much more soluble than magnesium hydroxide because down the group solubility of group 2 hydroxides increases, which is why examiner is writing such a statement that compound E is much more soluble than magnesium hydroxide. A saturated solution of magnesium hydroxide, in water has a concentration of this at 298 Kelvin. Calculate the solubility product of magnesium hydroxide including units. That's easy. In the first step, let's dissociate magnesium hydroxide into magnesium ions and hydroxide ions. We know that magnesium hydroxide and magnesium ions has 1:1 ratio. So if the concentration of magnesium hydroxide is 1.40 into 10 to the power minus 4, how about the concentration of magnesium ions? Obviously, it's going to be same because of the same molar ratio. 1.40 into 10 to the power minus 4 molar. Okay. As you can see, magnesium hydroxide and hydroxide ion has 1:2 ka ratio. So how about the concentration of hydroxide ion? Obviously, it's going to be doubled the concentration of magnesium hydroxide because I'm going to multiply this value into 2. So 1.4 so it's going to be 2.8 into 10 to the power minus 4 molar. Now let me write the KSP expression in my second step. Its concentration of magnesium ions, its concentration of hydroxide ions, since it has 2 mole. So number of moles needs to be in power. Concentration of magnesium ion is given, which is 1.40 into 10 to the power minus 4. Concentration of hydroxide ion is given, which is 2.8 into 10 to the power minus 4. Square karenge. Let me find out the value. Into 1.40 exponent minus 4. So it's 1.09 into 10 to the power minus 11. 0.097 into 10 to the power minus 11. And the unit is mole cube bm minus 9 because जब unit multiply हो रहा हो तो powers add हो जाते हैं. Okay. अगर मैं इसको round off करके लिखूं तो it's going to be 1.1 into 10 to the power Okay, 1.10 into 10 to the power minus 11. Unit is mole cube, dm minus 9. यूनिट कैसे पता चल रही है? ये मोल पर डीएम क्यूब है, ये मोल स्क्वायर डीएम माइनस 6 है, ये दोनों यूनिट्स मल्टीप्लाई होंगी तो पावर ऐड होने से ये आ जाएगी आपके पास. Explain why compound E is much more soluble than magnesium hydroxide. Down the group, ionic radius increases. Charge density decreases. Both hydration enthalpy and lattice energy decreases. Since in this hydroxide ion scenario, lattice energy is a deciding factor, so it decreases more significantly than hydration enthalpy. Which is why solution becomes exothermic. Hence, standard enthalpy change of solution becomes exothermic. And therefore, solubility of compound E is greater than magnesium hydroxide. So that's a lengthy question, and we have done that. Next question. Predict and explain the variation in the enthalpy change of hydration for halide ions. Okay. So first of all, down the group, ionic radius of halide ions increases, or down the trend, ionic radius of halide ions increases, which means weak electrostatic attraction exists between ion and water molecule, which is why hydration enthalpy becomes less exothermic. Which is why hydration enthalpy is less exothermic. One more thing, Instead of writing electrostatic attraction, you can write ion dipole attraction also. That term is also acceptable in the paper. Okay. Oh my goodness. Part B. It's different. Somewhat we have done in the class. It's slightly different, I believe. Okay. Let's check what's given in part B. Figure 2.1 shows an incomplete energy cycle involving calcium fluoride. Calcium fluoride is an ionic compound. We have incomplete cycle. Okay. These are the constituent elements under standard condition converting into 1 mole of compound, which means formation of calcium fluoride. This is calcium solid. This is calcium ion gas. This is molecule. This is gaseous fluoride ion, which means this step has multiple. This stage has multiple enthalpy changes like formation and this. Okay. Oh, that's tricky. When gaseous calcium ion and gaseous fluoride ion, then obviously it turns into aqueous calcium ion because of hydration enthalpy and aqueous fluoride ion because of hydration enthalpy. Okay. So this is going to be the standard enthalpy change of solution. This is going to be the formation. This is going to be the hydration of cation and anion. And this is general sort of stage. For one more thing. Okay, one more thing. So I've done complete the line D, include state symbols. I've done that. Let's move on to the next part. The value of enthalpy change for process 1 can be calculated using the values of 5 other enthalpy changes which are not referred in figure 2.1. The process 1 is represented by this. Identify these 5 enthalpy changes. First of all, we have calcium solid. Obviously, it turns into gaseous calcium atom. Then gaseous calcium atom is converted into gaseous calcium plus ion. Then gaseous calcium plus ion will turn to gaseous calcium ion. Okay. So this is atomization of calcium. First ionization energy of calcium. Second ionization energy of calcium. On the other hand, we have fluorine molecule gas converting into 2 fluoride ions. So it's basically atomization of fluorine. Oops. Atomization of fluorine. Oh my goodness. This is atomization of fluorine. In the next stage, gaseous fluorine atom will gain electron and convert it into gaseous fluoride ion. And that's electron affinity, okay? So, which means we have atomization of calcium. First ionization energy of calcium. Second ionization energy of calcium. ये हमारा first stage, ये हमारा second stage, ये हमारा third stage. Now the fourth stage is atomization of fluorine, and the fifth stage is first electron affinity of fluorine. Okay. Oh. So जब ये पूरे stages बनेंगे तो हमें ये दो चीजें मिल जाएंगी. ओके, और यही दोनों चीजें यहाँ लिखी हुई हैं। गॉट इट? Okay, next is define lattice energy. The enthalpy change occur when one mole of ionic solid is formed from its gaseous cation and anion under standard condition. Okay. Next is complete the expression to give the mathematical relationship between lattice energy of calcium fluoride and enthalpy changes for the processes 1 and 3. My goodness. Ooh. Lattice energy. Let's back to the cycle now. When gaseous, okay, makes sense. Makes sense. Wait. Let me draw this line to this extent so that we can discuss enthalpy change of or lattice energy. When gaseous cation and anion combine together to give 1 mole of ionic solid, then it becomes lattice lattice energy, right? So this arrow is going to be the lattice energy one. So examiner is looking for process 1 and process 3, which means these two process equals to this one. Okay. These two process equals to this one. Okay. These two process equals to this one, meaning how can we write that? So let me write it. Lattice energy is equal to this and this. Since this arrow is downward and this arrow is also downward, which means I'll take this value as the positive one. Standard enthalpy change of formation of calcium fluoride. Okay. And since this arrow is opposite to lattice energy, which means I'll take these two values in the negative with a negative sign. All right. So जो मैच कर रहा है एरो उसकी वैल्यू को प्लस ले रहे हैं हम, और जो मैच नहीं कर रहा लैटिस एनर्जी के एरो से उसकी वैल्यू को ऑब्वियसली हम माइनस कंसीडर करेंगे. सो इट्स गोइंग टू बी माइनस डेल्टा HF ऑफ कैल्शियम आयन गैसियस माइनस डेल्टा HF ऑफ, इनफैक्ट 2 आएगा because we have 2 fluoride ions. Okay. That is the relationship actually. An examiner is looking for, let me write this expression. सही है, ये मैंने expression generate किया एक्सप्रेशन जनरेट करने के बाद मैं इस एक्सप्रेशन को यहां लिखता हूं, यहां लिखा मैंने इस एक्सप्रेशन को. नाउ वी नीड टू फाइंड आउट द लैटिस एनर्जी, राइट? सो अगर मैं लैटिस एनर्जी डिटरमाइन करना चाहता हूं, लैटिस एनर्जी इज इक्वल्स टू ये हो नहीं सकता. हम्म, नहीं मैं इसको भी ओके. आई डोंट नो व्हाट आई एम डूइंग. ओके, आई मेड अ मिस्टेक. आई थिंक ये नहीं होना चाहिए. तो होल्ड ऑन, मैं बताता हूँ क्यों नहीं होना चाहिए. आपको याद है मैंने बॉन्ड हाइब्रिड साइकिल में आपको एक फॉर्मूला दिया था, डेल्टा एच एफ इक्वल्स टू समथिंग करके, राइट? सो आई एम गोना यूज दैट कॉन्सेप्ट अगेन. सो दिस इज डेल्टा एच एफ of calcium fluoride equals to this stage and this stage. We need to add all of them. So formation of calcium ion gas plus formation of fluoride ion gas plus lattice energy. All right, that's what we have done in the class, if you remember. So that was the relationship we have used in the class. और अब मैं इस रिलेशनशिप को यूज करके डेल्टा एच की वैल्यू डिटरमिन करने की कोशिश करता हूं. Let's apply this concept here. That's little bit tricky. So अगर मुझे डेल्टा एच लैटिस कैलकुलेट करना हो, so it's going to be delta HF of calcium fluoride minus delta HF of calcium ion minus delta HF of fluoride ions. That is the whole scenario. That's easy. तो अगर मैं इसको ऐसे रखूंगा, ये वहां चले जाएंगे तो ये माइनस हो जाएंगे. ओके, सो दैट्स द होल केस. ओके, या seems fine. This part is tricky. Use data from table 2.1 to calculate a value for the hydration enthalpy of fluoride ions. Hydration enthalpy अगर आपको fluoride ions की determine करनी है तो हमने आपको एक formula दिया था, standard enthalpy change of solution equals to minus lattice energy plus hydration enthalpy. Okay, so इस डेटा में एग्जामिनर ने मुझे सोल्यूशन की वैल्यू तो दे दी है और हाइड्रेशन ऑफ कैल्शियम आयन दे दिया है, फ्लोराइड आयन कैलकुलेट करना है, लेकिन इन दो प्रोसेस को यूज करके आई नीड टू फाइंड आउट द वैल्यू ऑफ लैटिस एनर्जी. ओके, आई नीड टू फाइंड आउट द वैल्यू ऑफ लैटिस एनर्जी. If I'll use this relationship, I can find the value of lattice energy. let me use this expression here. So this is delta H lattice. We know the formation of calcium fluoride, which is minus let me plug in the value, minus 1214. This minus will remain as it is. And instead of giving these two values, examiner has given us the overall value of these two steps, okay, which is plus 1395. So it's minus 1214 minus 1395. Let me calculate the value of lattice energy from here. 1214 plus 1395 is going to be 2609. Okay, so solution value is already given in the chart, which is plus 13, minus as it is. Lattice energy is minus 2609, plus hydration of cation is given, which is minus 1650, plus hydration of fluoride ion. We need to find out that because that's the question. Okay, which means we need to consider it as X. And since we have two fluoride ion in the formula, so I'm going to use 2X for fluoride ions. Let me calculate the value. Plus 13 equals to plus 2609 plus, sorry, minus 1650 plus 2X. So the value of X from here is going to be minus 473 kilojoules per mole. Okay, I hope it makes sense to you. By the way, this is the first step and this is going to be the second step. Okay, define entropy. Entropy is easy. The disorderness of the system is basically entropy, and disorderness of the system का मतलब क्या होगा? So disorderness of a system in which in which energy dispersal takes place from system to surrounding and vice versa. Okay. Next, at 298 Kelvin, the Gibbs free energy change for the solution of compound T is this. So we know the Gibbs free energy value. The enthalpy change of solution of compound T is given, temperature is given. Calculate the value of the entropy change for the solution at compound T. Okay, so I'm going to use delta G equals to delta H minus T delta S. Yes, minus T delta S. So delta G is plus 6.00, delta H is plus 30.0, minus T is 298 Kelvin, and we need to find delta S. Okay. So by using obviously delta S has to delta S, the unit of delta S is joule, whereas this is kilojoule, this is kilojoule. So I'll convert them into joule. So 1 joule equals to 1000 kilojoules, right? So let me convert this value into kilojoules, which is going to be plus 6000. Let me convert this value also in joules, which is going to be plus 30,000 minus 298, and then we have delta S. So the delta S here will give you how much answer? Plus 80.54 joules. So plus 80.54 joules. Okay. One more thing, this value is given in kilojoule, this value is given in kilojoules, but delta S has to be in joules. So we need to convert kilojoule into joules. All right. Predict whether compound T becomes more or less soluble as the water is heated from 298 Kelvin to 360 Kelvin. Explain your answer. Okay. Delta G equals to delta H minus T delta S. Delta H is basically positive. All right. Examiner is giving you this value. It is positive, right? And delta S is also positive. So plus will remain as it is. This minus plus becomes minus. All right. So when you increase the temperature, when you increase this temperature, the whole T delta S term will becomes more negative. So delta G becomes more negative at high temperature. And if delta G becomes more negative at high temperature, which means reaction is going to be feasible. And therefore, if the reaction is feasible, obviously, it's going to be more soluble in water at high temperature. Okay. So, delta S is positive. Delta H is positive. Increasing the temperature, makes T delta S term becomes more negative. So delta G is negative. Hence, compound T is more soluble in water. So that's the end of this question. Oh, these are the long questions, guys. Let's start question number 3. A and B react together to give product AB. We have done this sort of example in reaction kinetics, if you remember. You can go and check second order reaction, all right? I've given you this example. When the concentration of A and B are both 0.01 mole per dm cube, the rate of formation of AB is this. Okay. So in the first experiment, concentration is 0.0100. In the first experiment, the rate of reaction is 7.62 into 10 to the power minus 4. Okay. In the second experiment, when the concentration of AB both 0.02 the rate of formation of AB is this. So when the concentration increases from 0.01 to 0.0200, the rate of reaction is going to be 3.05 into 10 to the power minus 3. Now from this information, what we conclude is that look at this, concentration is doubled. So rate double हो रहा है. Let's check. Hold on. 7.6 to exponent minus 4 times 2. Rate double नहीं हो रहा. 7.6 to exponent minus 4 into 3 करें. Rate triple हो रहा है. Rate triple नहीं हो रहा. 7.6 to exponent minus 4 into 4. Exactly. So यहां से यहां जा रहे हैं आप, तो रेट is 4-fold हो रहा है. So if concentration is double and rate is quadruple or 4-fold, then order is first, right? यही पढ़ा था ना हमने. तो इन दोनों वैल्यूज से हमने ये कंक्लूजन ले लिया. If rate, my bad, if concentration is doubled, rate is 4-fold, then order is second. इसका मतलब इस रिएक्शन के लिए सेकंड ऑर्डर है ओवरऑल. वो कह रहे हैं कंप्लीट 3 possible rate equations that are consistent with this data. So मुझे सेकंड ऑर्डर बताना है. तो सेकंड ऑर्डर के लिए मैंने क्लास में बताया था कि रेट इक्वल्स टू के concentration of A and concentration of B. So with respect to A क्या हो जाएगा फर्स्ट, with respect to B भी क्या हो जाएगा फर्स्ट. So ओवरऑल ऑर्डर क्या हो जाएगा सेकंड. हमने इसी इक्वेशन को क्लास में इस तरह से भी तो लिख के दिया है. रेट इक्वल्स टू के कंसंट्रेशन ऑफ ए, सिंस इट इज सेकंड ऑर्डर तो हम यहाँ स्क्वायर कर देते हैं, जबकि कंसंट्रेशन ऑफ बी यहां पर क्या हो जाएगा 0. सही है. ये भी तो हो सकता है कि रेट इक्वल्स टू के कंसंट्रेशन ऑफ बी पावर स्क्वायर, जबकि इस केस में कंसंट्रेशन ऑफ ए क्या हो जाएगा 0. सही. सो मुझे टेक्निकली सेकंड ऑर्डर रिएक्शन के लिए ना रेट इक्वेशन लिख के दिखानी थी. तो रेट इक्वेशन इंडिविजुअल विद रिस्पेक्ट टू ए भी हो सकता है, विद रिस्पेक्ट टू बी भी हो सकता है, एंड विद रिस्पेक्ट टू दीस टू रिएक्टेंट्स भी हो सकता है. ये दोनों मैंने आपको क्लास में करके दिए हैं. चेक कीजिएगा नोट्स में. ओके. Choose one of the rate equations you have written in one and calculate the value of the rate constant k includes units. तो मैं टेक्निकली क्या करता हूं, मैं फर्स्ट ले लेता हूं एक्सपेरिमेंट. रेट इक्वल्स टू के कंसंट्रेशन ऑफ ए एंड कंसंट्रेशन ऑफ बी. रेट की वैल्यू हमारे पास है 7.62 into 10 to the power minus 4 equals to k. Concentration of A is basically 0.0100 और concentration of B is also 0.0100. So यहाँ से k की value is going to be check 0.01 into 0.01. Okay, 7.62 exponent minus 4 divided by answer. So it's 7.62. Okay, so 7.62 is the answer. Unit, so rate की unit is basically mole per dm cube second inverse. K की यूनिट हमें डिटरमिन करनी है. इसकी यूनिट है मोल पर डीएम क्यूब, इसकी भी यूनिट है मोल पर डीएम क्यूब. दोनों यूनिट्स मल्टीप्लाई हो रही है तो पावर स्क्वायर हो जाएगा. तो ये हो जाएगा मोल स्क्वायर डीएम माइनस 6. सो यहां से यूनिट हो जाएगी हमारे पास mole inverse dm cube second inverse. So I'm going to write this unit, mole inverse dm cube second inverse. I hope it makes sense to you कि ये unit इससे कैंसिल होगी तो आपके पास 1/mole per dm cube आएगा into second inverse, और फिर हम उसको रीअरेंज करेंगे तो हमारी फाइनल यूनिट ये बनेगी. Explain why it is not possible to calculate a value of the half-life of this reaction using the value of the rate constant calculated in 2 and the equation. So I can't use this equation because it is a second order reaction, and for second order reaction हम ये use नहीं कर सकते formula because this formula is only applicable for first order reaction. तो अब लिखेंगे this given formula is only used for first order reaction since this reaction as second order, so we can't use it. Okay. Okay, catalyst may be homogeneous or heterogeneous. So if catalyst exists in same physical state, then it becomes homogeneous catalyst. If catalyst exists in different physical state, then it becomes heterogeneous catalyst. Okay. Identify two metals that acts as heterogeneous catalyst in the removal of NO2 from exhaust gases from the car engine. So this reaction usually takes place in catalytic converter, and in catalytic converter, I've used rhodium and platinum. We have done this reaction in AS chemistry. Now in the next, iron acts as a heterogeneous catalyst in the Haber's process. Describe the mode of action of this iron catalyst. I have told you in the class, I have given you the entire mechanism of this heterogeneous catalyst, okay, in the class. So first of all, adsorption takes place onto the surface of catalyst via active site. Via active sites. Due to which old bonds are broken and new bonds are formed. Through series of steps, right? And then the sorption takes place in which product will leave the surface of the catalyst. Iron 2 ions acts as a homogeneous catalyst. When iodide and persulfate ions react together, write equation for the two reactions that occurs when iron 2 ions is added to the mixture of these two substances. I have discussed this in I think May June variance 41, yeah, and I've told you कि या तो आप ये equations याद करें या फिर आयन इलेक्ट्रॉन रूल के थ्रू बैलेंस करें. तो मैंने लास्ट जो पेपर था जून 2024 वेरिएंस 41 उसमें मैंने सिखाया था आपको. So this is iron 2 ions converting into iron 3 ions, and obviously sulfate ions are formed. Let's balance sulfur. We have 2 sulfur here, put 2 here. We have 8 oxygen atom here. We have 8 oxygen atom here. We have 2 minus charge and 2 plus. That's 0. Over here we have 3 plus and 4 minus. So it's basically minus 1. So we need to balance the charge. In order to balance the charge, I'll put 2 here and 2 here. Now the charge is balanced. See, 2 times 3, 6 plus. 6 plus and 4 minus plus 2. Over here, plus 2. Now iron 2 ions, iron 3 ions oxidize iodide into iodine, and as a result खुद reduce हो जाएंगे. तो reaction start हुआ aqueous iron 2 ions से, reaction के end में iron 2 ions recover हो गए, acts as a homogeneous catalyst. Or why homogeneous catalyst? Because reactants and catalyst exist in same physical state. By the way, this Fe3 plus ion is acting as an intermediate. So when you cancel out this, you will get the final equation like this: S2O8 2 negative plus 2 iodide ions, arrow I2 plus 2 sulfate ions. Okay, because you can cancel out these ions also. That was the equation usually examiner given in the paper. Okay. Anyhow, let's move on to the next part. Explain the difference between a homogeneous catalyst and a heterogeneous catalyst. Homogeneous catalysts exist in same physical state. Catalyst and reactants exist in same physical state then it is called homogeneous catalyst. And if catalyst and reactants exist in different physical state, then it becomes heterogeneous catalyst. Okay. Oh my goodness. Iron 2 ions can be oxidized to iron 3 ions under alkaline condition by suitable oxidizing agent. Iron is a transition element. Explain why iron forms stable compounds in both +2 and +3 oxidation state. Variable, any transition element shows variable oxidation state because of the fact that electrons are available in both 4s and 3d orbital, and both the orbitals have close energy gap also. Okay. Electrons are available and 3D and 4s also due to close energy gap. Next, the half equation for the reduction of iron 3 ions under alkaline condition is given. But select two oxidizing agents that can oxidize iron 2 ions to iron 3 ions under alkaline condition. So if I need two oxidizing agents that can oxidize iron 2 ions into iron 3 ions, obviously the value needs to be greater than this one. And इस तरह की value सिर्फ इन दो half cells के अंदर है, which means I'm going to use either ClO negative or oxygen. So oxidizing agent 1 is basically ClO negative. Equation is ClO negative. So do we need to write the overall equation or what? Or the half cell equation? Oh, I think so. We need to write the overall equation because examiner is looking for the E naught cell also. So since this half cell has a more positive SEP value, so I will take this half cell in the reduction form. I will write it down as it is, and I need to flip this equation. Okay. So when I'll flip this equation, and also I need to multiply by 2 with this equation because we need to balance the number of electrons. Okay. So first इस equation को as it is लो. Second इस equation को 2 से multiply भी करना है और flip भी करना है. So after flipping and all that, मैं डायरेक्ट लिख रहा हूँ. हाँ, FeOH taken 2 plus OH negative arrow Cl negative plus 2 OH negative. This is 2 also. My bad. Cl negative plus 2 OH negative plus FeOH taken 3. In fact, you can cancel out these hydroxide ions also, okay? But examiner is give you the. So let's remove these two. Let's cancel out these two hydroxide ions. So the final equation would be like this: ClO negative plus H2O plus 2FeOH taken 2 arrow Cl negative plus 2FeOH taken 3. Okay, we need to put 2 here because 2 se multiply out of. So the E naught cell, E naught right, which is plus 0.89 minus 0.59. So the value of E naught cell is going to be plus 1.45 volt. Okay. Now the oxidizing agent 2 is going to be oxygen. So we need to merge these two equations. Obviously, this value has a more positive SEP value. I'll take this equation in the reduction form, and I need to flip this equation. After flipping, I need to multiply this equation by 4 as we need to balance the number of electrons. After the cancellation of electrons, we can cancel the hydroxide ions also. Okay. So let me write it down, the overall equation directly. O2 plus 2 H2O. 4 से मल्टीप्लाई करेंगे तो 4 FeOH taken 2. Hydroxide ions will cancel out with each other. Will turn to 4 FeOH taken 3 plus, that's it, Okay, hydroxide and cancel हो गए. That's it. So in order to calculate E naught cell, let me plug in the value in the formula. Its value is plus 0.40 volt minus, its value is minus 0.59 volt. So the value of E naught cell is basically plus 0.96 volt. That's the end of this question. Question number 4. So let's start question number 4. Transition elements and metal ions forms complexes by combining with ligands. Explain why transition elements forms complex ions. Because empty orbitals are available. Those empty orbitals are available. Oh my God. And so ligand can donate their lone pair to such orbitals, to such empty orbitals. Cobalt 2 ions forms complex ion G. Each G ion contain 2 cobalt 2 ions. That's very, very important. एक G बनता है, इस G में 2 cobalt ions हैं, and both of them have octahedrally coordinated. That means coordination number is 6. 6 dative bonds are formed. Okay. Each G ion contain 1 oxygen molecule, which donates 1 pair of electron to each cobalt ion. So 1 molecule है और 1 lone pair donate कर रहा है to each cobalt ion, and 1 NH2 ion है which donates 1 pair of electron to each cobalt ion. The remaining ligands are ammonia molecule. Deduce the formula of the complex ion, include its overall charge. That's the craziest thing I have ever seen. First of all, the coordination number of cobalt 2 ions would be 6. Okay. This is cobalt 2 ions. Let me remove this line. This is dotted line. This is pyramid. This is dotted line. And this is pyramid. Let me make the same diagram again because we have 2 cobalt ions. Okay. Now we have 1 oxygen molecule, and each oxygen donates 1 lone pair to each transition element. So it donates only 1 lone pair. It donates only 1 lone pair to this cobalt ion. We have one NH2. So this is going to be the NH2 thing. ये इसको डोनेट कर रहा है, ये इसको भी डोनेट कर रहा है. And the remaining ligands would be ammonia. 1, 2, 3, 4. 1, 2, 3, and this one is 4. That's the structure I can suggest. Now look at this. It is octahedrally arranged. This cobalt ion is also octahedrally arranged. By the way, this cobalt ion has a 2+ charge. This cobalt ion has a 2+ charge. Okay. So how many cobalt ion technically in this G2? How many oxygen? 1. How many NH2? 1. And how many ammonia? I think it's 8. So that's the formula of G. But again, we need to check the overall charge. How can we calculate the overall charge? Look, this cobalt has 2+, this cobalt has 2+. So in total, it has a charge of 4+, right? And the charge of NH2 is -1. It's given in the question. So if 4+ and -1 becomes +3, the charge is going to be +3. Okay. That's my assessment for this structure because that's the only possibility I can think about it. Okay. Yeah. Yeah. That's the only possibility I can think about. Let's move on to the next part of the question. The d orbitals of the cobalt 2 ions present in complex ion G are split. State the number of d orbitals that are at a higher energy level and the number of d orbitals that are at the lower energy level in this. Since the structure is octahedral, so whenever octahedral complex exists, the degenerate d orbital is split into two different energy groups. The lower energy group contain 3 orbitals, which is dxy, dxz, and dyz. The higher energy level group contain 2 orbitals, which must be dx square dash y square and dz square. Okay, we have done that part in the splitting of d orbital. Cobalt 2 ions forms different complex ions. Each metal ion contain 2 cobalt ions, both of which are octahedrally coordinated, but the ligands are different from the ligands in G. Explain why G and M have different colors. Different ligands have different colors. We know that. That's so obvious. So different ligands have different colors. In fact, different ligands have dif different strength. Different strength. So they have different splitting. Different splitting of d orbital. So energy absorption. takes place for electron promotion in a visible spectrum this electron promotion is also called DD electronic transition, and therefore its complementary color is observed. That's the explanation I can think about. Let's move on to the next page. Cadmium forms complex ion when a solution containing cyanide ion is added to aqueous solution of X, ligand exchange reaction takes place. Okay. This is cadmium, NH3 taken 4, 2 plus. And when you treat it with cyanide ion, which is a stronger ligand, if you remember, then ligand substitution reaction takes place. And as a result, complex becomes CdCN taken 4, 2 minus, plus 4 ammonia. Okay. Now, examiner is saying when Y contain no ligand and no water ligand, Y is a much higher concentration in the mixture than X. What does it mean? It means that complexes which are formed through cyanide are more stable than the complexes which are formed through ammonia, which is why this complex has a higher concentration than this one, because equilibrium favors towards right hand side as the stability constant of this complex is greater than this one, right? The oxidation state and coordination number of cadmium do not change in this reaction. Write ionic equation for this reaction using the formulae of the complex ion. That's what I have done. That's what is examiner looking for. Cadmium, NH3 taken 4, 2 plus 4 cyanide ions. Cadmium, cyanide 4, 2 minus, plus 4 ammonia. Okay. I hope you get the logic. Since ammonia is a neutral ligand, which is why it has a charge of 2 plus. Since cyanide is a negative ligand, so in order to get the oxidation state of in order to get the +2 oxidation state of cadmium, we need to put 2 minus charge here. We have discussed such sort of things in the class, and you know, ये सब कुछ count होता है, ये सब कुछ use होता है paper के अंदर, because that's the concept. Cadmium forms complex ion Z in the same oxidation state with the same coordination number as in X. All ligands in Z are chloride ions. When sodium chloride is added to the solution of X, very little Z is formed. Very little Z is formed. That means complexes which are formed through chloride ions are less stable than the ones which are formed through ammonia molecule, right? That means this complex with chloride ions has lower value of stability constant than this one. So the most stable complex with a higher stability constant value shows this sign, the lower one with this, and the lowest one is that. So write 3 cadmium complexes X, Y, and Z in order of increasing stability constant. When we react cadmium with chloride ions and ligand substitution reaction takes place, and as a result CdCl4 2 minus is formed. So technically, this complex has the lowest value of stability constant because it exists in a very small amount. So this is CD Cl4 2 minus. Obviously, this complex has a higher concentration, so its value, stability constant value, is the highest one. And obviously, this complex is more stable than the chloride one. God. Next is ethane dioate ions forms complexes with transition element ions. The concentration of ethane dioate ions can be found by reacting with acidified potassium dichromate 6. Ethane dioate ions are protonated and form ethane dioic acid molecule, which are oxidized by this ion. Equations are given. Construct an equation for the reaction between this and this. So, okay. Let me rearrange the equations. Cr2O72 negative plus 14 hydrogen ion plus 6 electron arrow 2 chromium 3 plus 7H2. So इस equation को तो मैं as it is रखूंगा because I need dichromate 6 ions on the reactant side so that it can react with ethane dioic acid. Since I need ethane dioic acid on the reactant side, which is why I need to flip this equation. When you flip this equation, you will get this equation now. We need to balance the number of electrons, and so we need to multiply this equation by 3. As soon as the number of electrons are balanced, they will cancel out with each other. And obviously, these hydrogen ions can also cancel out with each other. Now I can write the final equation, and obviously I'm going to write the final equation here, okay, straight away directly. So it's Cr2O72 negative plus 3 moles of ethane dioic acid plus 8 hydrogen ion left here after the cancellation, 6 carbon dioxide plus 2 chromium 3 plus 7H2. That's my final equation, okay? (25 cm cube sample of solution. That's sodium ethane dioate reacts exactly 16.20 solution of 0.05 mole per dm cube of potassium dichromate 6. Calculate the concentration of sodium ethane dioate salt. So that's an easy piece of calculation. We know the concentration, we know the volume. I can find the moles of dichromate 6 ions. Moles of Cr2O7 0.05 into 16.20 divided by 1000. So I'll get how much? Let me calculate. 0.05 into 16.2 divided by 1000. So it's going to be 8.1 into 10 to the power minus 4 mole. Okay. Now in the second step, I know that dichromate 6 ions and C2O42 negative ions has 1:3 ka ratio according to the equation. It doesn't make any difference if you write ethane dioic acid or its anion. It doesn't make any difference. It's the same thing. So अगर हमने 8.1 into 10 to the power minus 4 moles calculate किए तो moles of C2O42 negative would be 2.43 into 10 to the power minus 3 moles. I've got the moles in this volume. So to calculate the concentration, I will compare it with 1000, right? So the next step, 25.0 cm cube sample of C2O42 negative contain 2.43 into 10 to the power minus 3 moles. Let's compare it with 1000 to get the concentration. Into 1000 divided by 25, I'll get what? 0.0972 mole per dm. So that's the end of question number 4. My God, that's tricky. Very, very tough. Oh God. Question number 5. The shapes of 4 different complexes P, Q, R, and S are shown in the table 1. The symbol J represents the atom or ion of a transition element. The L symbol represents the monodentate ligand. Okay. This has 109.5 degree. This has 90 degree. This also has 90 degree. And this has 180 degree. Okay. Which means label one bond angle on each of the complexes P, Q, R, and S. Identify the size of the angle in degrees. Okay, I did that. Identify the shapes of the complexes. The first shape is tetrahedral. Q. Q has an angle of 90 degree, and which means this structure is going to be square planar because the square planar geometry shows 90 degree angle. Then this one is octahedral. And this one is linear because it has an angle of 180 degree. 2L ligands are exchanged with 2 different monodentate ligands X and Y in each of the complexes P, Q, R, and S. Identify all the complexes which forms new complexes that shows geometrical isomerism. For geometrical isomerism, we need to remember one thing, that similar ligands present on the same site, it's going to be cis, and if they are exist in the opposite direction, obviously it's going to be trans. So linear geometry cannot show cis and trans. Okay. What we can do is let's talk about Q first. Do we have a space? No. Okay. Q. Hold on. That's tricky. That's not an easy thing. Oh. So this is J. This is L. This is L. This is L. And this is L. In a square planar geometry. So अगर मैं दो different लगा दूं, तो this is L, this is L, this is X, and this is Y. So अगर मैंने दोनों different कर दिए तो फिर क्या होगा? तो आप नोट करें, two similar group present on the same site, so it's going to be cis. तो अगर मैं इसको इस तरह से लिख दूं, L L Y and X, तो आप नोट करें, two groups present on the same side L, two groups diagonally attached, trans. This is going to be cis, this is going to be trans. Oh, that's nice. हम इसको इस तरह से भी तो लिख सकते हैं, वेट, ये सही था, गलत नहीं है, बट मैंने जो क्लास में पढ़ा है मैं उसको भी देख के अप्लाई करके दिखा रहा हूँ. ये J है, राइट, ये दोनों लिगेंड सेम रखिए, एंड ऑब्वियसली दैट्स गोना बी सिस बिकॉज सेम साइड के ऊपर अटैच हो गए. इसको X ले लीजिए, इसको Y ले लीजिए. ठीक, ये भी बिल्कुल ठीक है, लेकिन मैं इसको जो क्लास में मैंने करवाया मैं उसके रिस्पेक्ट से बात करूं तो ये इस तरह से हो जाएगा. ये L एज इट इज, ये L एज इट इज, ऑब्वियसली डायगोनली अटैच्ड होगा ट्रांस, एंड ऑब्वियसली ये X एज इट इज रहेगा, और यहां पर क्या आ जाएगा Y. So this is going to be your cis, this is going to be your trans. That's what we have done in the class. So I think this compound Q gives you geometrical isomerism. Okay. P, Q, R and S. S तो होगा नहीं. P पे देखते हैं. P पे आपके पास 4 ligands हैं. हम 2 ligands सब्स्टिट्यूट कर देते हैं, X and Y. All right. तो अब चेक करते हैं कि जनाब इसमें हो सकता है हो या ना हो. इसमें तो मुमकिन नहीं है. ये J है यार, J. माय गुडनेस. सो ये और ये टेक्निकली एक तरह से सेम ही हो गया है ना, तो इसमें तो नहीं होगा. Q में हो रहा है, लेकिन P के अंदर एग्जिस्ट नहीं करेगा क्योंकि सेम ही चीज आ गई है आपके पास, तो P में नहीं होगा बिकॉज इस स्ट्रक्चर में और इसमें कोई फर्क नहीं. ठीक है, सेम ही चीज हो जाएगी अरेंजमेंट के पॉइंट ऑफ से. अब R में देखिए, और आई होप आई कैन गेट द स्ट्रक्चर सो दैट उसको लिखना मेरे लिए आसान हो. ओह दैट्स फाइन. Okay, let's talk about R here. Yes, this is R. So if I'll substitute 2 ligands, this is L. Okay. This is L. This is L. Yes, I can do that. R में भी हो जाता है. ये देखिए, if we have a complex like this, let me show you one thing. This is JL6, right? So if I'll replace 2 different ligands, so it's going to be JL4 2 different X and Y. X and Y. So 4 similar in 2 different ligands. The situation is, so we can have a geometrical isomerism here. If you remember, we have done this sort of example in the class. All right. So how can I draw the structure? I can draw the structure like this. That's J, L, 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 L. This is going to be your Y, and this is going to be your X. Okay. So these two present on the same side of J, which means it is cis. और इसका ट्रांस भी बन सकता है, कुछ ऐसे हो सकता है ट्रांस. बट आई थिंक आर में भी होगा. Q and R. Three ligands are exchanged with three different monodentate ligands X, Y, and Z in each complexes P, Q, and R. Identify all the complexes which forms new complexes that shows optical isomerism. I'm looking for the optical isomerism. That's going to be tricky because three different monodentate ligands are used. An examiner is looking for P, Q, and R. P, Q, and R. So for P, Q, and R, तो सबसे पहले P की बात कर लेते हैं. ये J है आपके पास और इसके साथ उन्होंने थ्री डिफरेंट लाइगेंड्स अटैच किए हैं. सो एक अटैच किया है X, एक अटैच किया है उन्होंने Y और एक अटैच किया उन्होंने Z. सो ऑब्वियसली फोर डिफरेंट लाइगेंड्स आर अटैच्ड to this element, which means this shows optical isomerism just like a chiral carbon atom. So ये इस तरह से शो करेगा. L, X, Y and Z. ये इसका मिरर इमेज आ गया. This is L, this is X, this is Y, this is Z. Okay. So P shows optical isomerism just like chiral carbon. Okay. Let's talk about Q. Q में J है और आप तीन डिफरेंट कर देंगे तो ये सेम ही सिनेरियो हो जाएगा. X, Y and Z. ये एग्जैक्टली सेम सिनेरियो हो जाएगा Q में भी. In fact, if it has a square planar geometry, obviously इसका मैं mirror image so it's going to be L. All right, so we were discussing what if we have Q. So let's talk about Q here. So this is L, X, Y and Z, and obviously इसका mirror image कुछ इस तरह का बनेगा. So जब ये mirror image बनेगा तो it's going to be L, Y, X and Z. So ये दोनों एक दूसरे के ऊपर सुपर इम्पोज होते हैं, जबकि नॉन सुपर इम्पोजेबल होनी चाहिए सिचुएशन, इसका मतलब क्यू में एग्जिस्ट नहीं करेगा ये। ओके, सो क्यू में तो एग्जिस्ट नहीं करेगा, पी में कर लेगा, क्यू में नहीं करेगा। लेट्स टॉक अबाउट आर। आर आपके पास ये है, ठीक है। और अगर मैं इसको सब्स्टिट्यूट कर दूं 3 डिफरेंट लाइगेंड्स के साथ, सो 3 डिफरेंट लाइगेंड्स की सिचुएशन ये बनेगी। लेट्स सपोज ये L, ये भी L, ये भी L, ये 3 सिमिलर हो गए और 3 डिफरेंट हैं। तो ये हो गया X, ये हो गया Y एंड दिस इज गोइंग टू बी Z। तो लेट्स चेक इस ये नॉन सुपर इम्पोजेबल है या नहीं। सो अगर ये नॉन सुपर इम्पोजेबल होगा तो ये कुछ इस तरह से हो, होल्ड ऑन, ये कुछ इस तरह से होगा, ये L, ये L, ओ माय गुडनेस। सो ये हो जाएगा बेटा, फ्लिप होने के बाद, और जब फ्लिप होगा तो ये एक्चुअली इस तरह से फ्लिप होगा कि ये यहाँ आ जाएगा, ये यहाँ आ जाएगा और ये, ठीक है। तो ये हो जाएगा L, 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 ये आ जाएगा X, ये हो जाएगा Y, ये यूं होगा तो ये Z होगा। वेट, दैट्स टेक्निकल, that's not an easy thing, that kind of a question usually don't come in the paper. So ये इस तरह से है, तो ये X, ये Z हो गया, ये Y हो गया, ये X हो गया और ये L हो गया। ओके, सही है। सो ये नॉन सुपर इम्पोजेबल है, विच मींस इसमें एग्जिस्ट कर जाएगा। ऑलराइट, सो R में भी एग्जिस्ट करेगा ऑप्टिकल आइसोमेरिज्म, बिकॉज मिरर इमेजेस एग्जिस्ट कर रहे हैं इसके। So P and R is basically the right answer in this. Let's move on to the next question. Question number 6. Benzene reacts with chloroethane in the presence of suitable catalyst to form ethyl benzene, which is basically an arene. In the presence of a catalyst, ethyl ion is formed, which will serve as an electrophile and which reacts with the benzene ring. So we need to determine how that electrophile is formed. So it's basically AlCl3. Okay. And as a result, you will get AlCl4 negative. Draw the structure. Ethyl benzene reacts with chloroethane, forming a mixture of containing 1,2-diethyl benzene and 1,4-diethyl benzene. Basically, this is going to be the ortho product and this is going to be the para product. This is ortho product and this is going to be the para product. Why are we getting 2 different products? Because ethyl group is an ortho para directing group, so it increases the electronic density on both ortho and para position. Para product. So I'll get 2 different structures here. This is CH2CH3. This is your ortho product, CH2CH3. And for para, it has to be like this. CH2CH3 and then CH2CH3. All right. So that's your ortho product. That's your parallel product. Explain why there is a very little 1,3-diethyl benzene in the product mixture, because ethyl is an activating group or to para-directing group. Increases the electronic density. Only on orthopara position. That is second and sixth. That is second, sixth, and fourth carbon atom. Which is why this matter product exists in a very trace amount. Okay. 1,2-diethyl benzene can be oxidized to benzene 1,2-dioic acid. Suggest reagent and conditions used for this. So to convert this group into CWH, I'm going to use K1O4. In the presence of an acidic medium. Heat under reflux. Complete overall equation for this reaction. Okay, 1,2-diethyl benzene. How many 1,2-diethyl benzene ka formula is this? C 1,2-diethyl benzene. Oh. How many carbon atoms, guys? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 carbon atoms हैं यहाँ. Hydrogen count करो. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 hydrogen atoms. So C10H14 is basically the answer. Okay. So C10H14 is basically 1,2-diethyl benzene. Reacts with oxygen to convert into this. How many hydrogens here? 4 and 2, 6. And how many hydrogen atoms here? 14. How much left? 8 hydrogen atom. 8 hydrogen and oxygen combine together to give water. Okay. All right. Look at this. How many carbon atoms here? 10. How many carbon atoms here? 6. So iska matlab carbon dioxide gas is also formed. And since we need to balance the number of carbon atoms, so if we have 6 and 2. Okay. How many carbon atoms we have? 8. How many carbon atoms we have? 10. So put 2 here. Carbon atom is balanced. Let's talk about hydrogen. We have 14 hydrogen atoms here. Talk about hydrogens now. 2 plus 4, 8. 8 plus 2, 10. 10. And we have 14. So 4 water molecule. So hydrogen is balanced. 4 times 2, 8. 8 plus 2, 10. 10 plus 4, 14. So carbon balance, hydrogen balance. Let's talk about oxygen. 2 oxygen here. 4 here. 4 plus 2, 6. 6 plus 4, 10. 6 plus 4. Wait. 2 times 2, 4. 4 plus 4, 8. 8. And 2 times 2, 4. 12. So we have 12 oxygen technically. So for 12 oxygen, I'm going to write 12 here. Predict the number of peaks in carbon-13 NMR spectrum of benzene 1,2-dioic acid. This is benzene 1,2-dioic acid. This carbon has same chemical environment. These two carbons have same chemical environment because attached to same functional group. इन दोनों कार्बन एटम सेम डिस्टेंस से अटैच हैं। थर्ड, ये दोनों कार्बन एटम भी सेम डिस्टेंस से अटैच हैं। फोर्थ, सो आई बिलीव देयर आर 4 केमिकल एनवायरनमेंट्स in carbon 13. All right. Next, the proton NMR spectra of ethyl benzene in CdCl3 and of benzene 1,2-dioic acid in CdCl3 are shown. They have not been identified. Okay. So यहाँ पर 3 peaks हैं, 3 chemical environments. We have 2 peaks, so which means we have 2 chemical environments. Let's move on to the next part of the question. Explain the use CdCl3 instead of CHCl3 solvent when obtaining these spectra. Well, deuterium cannot show absorption in radio frequency region, which is why it will not give you any sort of peak or cannot interfere with the proton of the sample. Deuterium cannot absorb radio frequencies, hence cannot interfere with the sample. Says this solvent contain hydrogen. So if I'm going to use this, obviously this hydrogen is going to interfere with the sample, and obviously you will not get a correct spectrum. So you cannot decide which sort of compound and proton exists in the molecule. All right. Let's move on to this. Identify the substance shown by the spectrum 6.1 and complete table 6.1. Okay. Spectrum. This is triplet. Obviously CH2 neighbor में होगा. This is quadrat. Obviously CH3 neighbor में होगा. This is basically benzene ring. Okay, because benzene ring appears from 6.9 to 7.4 delta. That's the chemical shift in which benzene ring exists. So basically this is benzene, this is CH3, this is CH2. It's basically ethyl benzene. This is ethyl benzene. Okay. So this is the structure of ethyl benzene. This will give you triplet. So peak at 1.2 is basically name of a splitting triplet. Group responsible for the peak, CH3. Explanation of the splitting pattern contain 2 protons in the adjacent carbon. Now at 2.6, you're going to get quadrate. And group responsible for the peak, CH2. Wait. This is CH3. CH3 is responsible for the triplet because CH2, and this is going to be CH2. Because 3 protons, I believe you can get the point, contain 3 protons in adjacent carbon. Okay. Identify the substance shown by the spectrum in figure 6.2 and complete table 6.2. This spectrum shows, I think, this shows CWH group, and this shows benzene ring, because of the chemical shift exists between 6.9 to 7.4. तो इसका मतलब बेंजीन और COH एग्जिस्ट कर रहे हैं, तो बेंजीन और COH किस में एग्जिस्ट करते हैं? वो इस कंपाउंड में एग्जिस्ट करते हैं। ओके, so it's going to be what? Benzene 1,2 dash dioic acid, 7.8 benzene ring, C6H4 because two groups are attached. Okay, and peak at 13.1 COH because COH की हमेशा offset peak होती है, spectrum से बाहर होती है. When D2O is used as a solvent, the spectrum obtained is different from the spectrum in figure 6.2. Obviously, when you treat this compound with D2O, proton is substituted with this deuterium, and as a result, the peak at 13.1 will disappear from the spectrum. COH peak at 13.1 delta will disappear. Because proton of COH is exchanged with deuterium. Okay. Benzene 1,2-dioic acid can be used to produce K. So obviously यहाँ से OH और यहाँ से H दोनों मिलकर बनाएंगे water, and obviously you will get this, and this is going to be the ester, by the way, right? So removal of water is basically the elimination, and removal of water is also called condensation. So you can write condensation also. Next question. A reaction scheme is shown in figure 7.1. The reagents needed for reaction 2 and reaction 3 are stated. Reaction 5 takes place when aminoethane is mixed with compound B. No special conditions are required. So compound U will turn to ethanoic acid. That indicates, and this same compound when treated with lithium aluminum hydride give you aminoethane. So iska matlab this compound needs to be nitrile, and it has to be 2 carbon ka nitrile, that is cyanomethane. So when you treat it with acid in the presence of water, condition reflux, CN will turn to COH. This CH3 will remain as it is. Now, when you treat it nitrile with lithium aluminum hydride, you will get CH3 will remain as it is. You will get CH2, NH2. That's your aminoethane. Okay. When ethanoyl chloride, when ethanoic acid react with thionyl chloride, obviously you will get ethanoyl chloride. That is CH3, CO, Cl. Now, when acyl halide and amine react together, you will get an amide. When amide, what? Okay, look at this structure. This CH2, H5 will remain as it is. NH will remain as it is. But this whole thing is getting converted into an alkyl group, which means I'm reducing amide. So for that, I need lithium aluminum hydride. And this amine is used when this amide is this amine is formed when these two compounds react together. So obviously it's going to be alkyl halide. An alkyl halide of how many? C2H5NH, C2H5, Cl. So when this alkyl halide and this amine react together, you will get this thing. Identify compound U. Where is compound U? CH3CN. Describe the reagents and conditions for reaction 1. So reaction 1 के लिए acid in the presence of water, condition is reflux. Identify compound V. Where is V? Ethanol chloride, CH3COCl. Complete the equation for reaction 3. So that's easy. We have done this in A1, also in A2. That's ethanol chloride, misty fumes of HCl, and we'll get sulfur dioxide. Okay. Identify compound W. What's W here? W is chloroethane, that is alkyl halide. You can use bromoethane or iodoethane also. I'm going to use chloroethane. Describe the conditions needed for reaction 4. Reaction 4 is condition. So just heat in ethanol in a sealed tube. Okay. Let's move on to the next. State the reagents needed for reaction 6. What is reaction 6? Lithium aluminum hydride. Because I'm reducing amide and turning them into amines. Complete table 7.1 by adding the reaction number to the right hand column. Use reaction number given in figure 7.1. Hydrolysis 1. Acid hydrolysis 1. Addition. Yes, this is addition reaction because addition of hydrogen is taking place. Reduction. So reduction तो 2 में भी हो रहा है, ठीक है. Reduction 6 में भी हो रहा है, 2 and 6. Substitution 4 में हो रहा है because HCl की substitution हो रही है. Substitution 3 में भी हो रहा है और substitution 5 में भी हो रहा है because H and Cl combine together to give HCl. So 3, 5 and 4. Okay. Compare the basicities of amide, amine and ammonia. So most basic is aliphatic amine, obviously C2H5NH, C2H5, and this is because we have 2 electron donating alkyl groups. So both of them have positive inductive effect, which is why lone pair is easily available for protonation. Okay. C2H5 NH C2H5 has a strong positive inductive effect. So electronic density on the nitrogen atom increases. So lone pair is easily available for protonation. If lone pair is easily available for protonation, इसका मतलब stronger base है. Just hold on a second, please. All right, so let's continue the explanation. Ammonia is weaker than this one, and amide is basically the least basic one. Why amide is weaker? So C2H5 NH CO CH3 is the weakest because lone pair of nitrogen is delocalized with a pi bond of oxygen atom. We have discussed that issue in the class, all right? Okay, that's the end of this question. Let's move on to question number 8. Explain why phenol is more acidic than water. Because it donates its cause it donate its proton easily. Reason is oxygen donate its lone pair into the benzene ring because OH is an orthopara directing group. So oxygen becomes electron deficient. Hence, removal of hydrogen becomes easier. Also, due to resonance, its anion is stable. Name the two products formed when phenol reacts with an excess of aqueous bromine. Two products. 2,4,6-tribromophenol. That will give you white precipitates during the reaction and HBr, obviously. Okay. Draw the structure of the two isomeric organic products, which has an MR of 139 when phenol reacts with nitric acid at room temperature. By the way, phenol has OH group, which is an orthopara directing group, so it increases the electronic density on both ortho and para position. Ultimately, nitration takes place, and so that you will get two different products. The first one is ortho product, in which NO2 is attached to either second or sixth carbon atom, because second and sixth both shows ortho. And the other one is para product. My bad. This is OH and this is NO2. Let me check MR सही आएगा या नहीं. Benzene has a mass of 78, तो 76 करो because 2 hydrogen चले गए. 17 add करो plus 14 add करो plus 32 add करो. So it's 139. Perfect. So both of them are isomers of each other, and both of them have an MR of 139. Okay. Write the equation for the reaction between phenol and sodium metal. That's very easy. So 2 moles of C6H5OH when reacting with 2 moles of sodium, converting into hydrogen gas, and 2 moles of salt, C6H5ONA. Okay. phenol can be produced from phenylamine in two-step synthesis. Describe reagents and conditions needed in each step. Phenylamine से आप क्या बनाना चाह रहे हैं? Phenol. So first of all, turn amine group into diazonium, and for that, I'm gonna use sodium nitrite and HCl as a reagent. Condition is going to be above 10 degrees Celsius. Okay. In the second step, I'm going to use water, and the condition is heat. So what I'm saying is, okay, when you add NaNO2 and HCl in the step 1 above 10 degrees Celsius, you will get diazoniamine. In other words, benzene diazoniamine भी कह सकते हो. When you add water under heat, so it will turn to phenol or nitrogen gas यहाँ से release हो जाती है. Okay, so that's the end of question number 8. Let's move on to the next question. So that's the end of this paper, guys.